Hey folks, James here with Rewind Electric. I wasn't expecting to throw this camera on real quick, but I'm gonna just do it. And hopefully I can find my little wooden pointer stick. And yes, I've got it here. This is extremely heavy. It is also the brute force magnet charger that I've been using for charging bar magnets, Alnico bar magnets at least, and Fender single coil pickups. You can kind of see it here. This thing weighs about 50 pounds. I just did something to it. First of all, let me explain what it is, and I'll explain what it is. You've got an AC power coming in. It hits a bridge rectifier here. Maybe it's a full wave, I don't know. And there is some filtration with these power capacitors here, some smoothing of the waveform, and then a DC voltage goes to these coils. I missed a step. So the AC comes in here. There is a fuse down there that it passes through, and then it goes to a momentary switch, which is right here. And then that switch powers the rectifier. Okay. So then the rectified DC voltage, lightly filtered, passes through these two giant electromagnets in parallel. Okay. So not like a humbucker, but well, not like a PAF humbucker, but in parallel. Okay, kind of like two Strat single coils in the 2 and 4 position. I guess that's a good way to put it. Very much like that. Okay, what I have done here now is I've added this double pole, double throw switch here, which it's a 16 amp switch. Actually, pulled that from an old Marshall, so it's got some mojo and some street cred for use in guitars. That is a plexi switch, and with the little bat at the end and all. And I wired that up so that it reverses the rectified DC voltage. Let's hope that that is enough. This is a 15 amp unit, as in it pulls 15 amps from the wall. Now, a switch that is rated for 16 amps DC or AC is not necessarily rated for 16 amps DC. In fact, usually much less. It's easier for a switch to handle the alternating current than it is the blast DC. So we're gonna not touch that switch while we're using the machine, and we're gonna see how it fares. I've tried to isolate things. There's really not a lot of space in here. I really hope this physically fits. As you can see, it barely might. Maybe I can even give this a twist to kind of tighten up some of those wires there. I want to keep them from laying directly on these coils too much. Something else that I did, I had thought about. Now, okay, why would I want to put a switch there? I guess that's an important point to discuss. Well, what if I want to reverse the charge on a magnet without removing the magnet from the charging fixture? Oh, this is a very tight fit. I don't know if I'm going to make it here. Oh boy. Let's see. Yeah, I think I'll barely make that fit. Well, previously this side was always south and this side always north, as you can see by the S and the N that I wrote on there, if you can see that. And that's, I don't know, that's maybe meaningful for, it did me well for a long time of using this charger, okay? You can reverse the magnet, you can reverse the pickup, but throughout these, and I've been using degaussed magnets for a long time. Here, let me just show you what I've been doing for that. I've got this series of blocks that I made. I haven't showed these previously, but as you can see, I routed into some hardwood. Technically, pine is a hardwood, although it's the softest of hardwoods and the most difficult to work with. I routed some channels, and then these are all, they have various sizes to them. And if you are, there we go. And I had a smaller one, but I broke it. If you can imagine that a magnet would lay right in there, just like that, a bar magnet, that's what they're made for, a little 1/2-inch channel. And then this sits, these two giant pole shoes sit on top and form the gap that you would normally place the magnet in. And so these provide an increasing amount with each size up of space between the magnet and the pole shoes. And that allows for this charger to not charge the magnets to saturation. The air gap reduces the magnetic flux present at the location of the magnet, which allows you to not charge the magnet fully. So what I would do is I would charge them fully in one direction and then use an appropriate spacer. And I've got a chart that I've made with my various magnets that I update now and then and say, like, okay, this spacer, you know, creates this amount of a charge in the magnet if you use it to knock the charge back afterwards. And that way I can degauss them to, you know, what did I have there? 7 different degrees with those blocks, okay? And that's been pretty great. But I'd like to do it in a more, I mean, that is a pretty controlled way, in a pretty exact way, but I'd like to do it in a more adjustable way. Maybe I want increments in between those magnets, and in an easier way, rather than charging it, taking the magnet out, moving the fixtures, placing in a block, putting the fixtures back, tightening them down, and then charging the magnet in the other way. So now with this switch, this is going to basically point towards north, I think, unless I've installed it upside down. So north that way or north that way. And that way I can charge fully and then reverse the charge a little bit and charge backwards a little bit to take that down and degauss it a little in one shot. Now, how will I reduce the power? Okay, I also bought a 20 amp variable transformer. So I have multiple variacs. I tested it with a 10 amp, but it's not sufficient and it's not safe. I could not bring it up past 10 amps to really fully saturate even an unoriented A5, much less an oriented A5, an A8, A9, or a ceramic. This has about 2,500 amp turns, which is how you measure the power of an electromagnet, and that is sufficient for magnetizing ceramic magnets as used in modern and vintage guitar pickups, just barely. So with that 20 amp variac, I have about 5 amps of headroom beyond the capacity of this, so that I'm not running that at the edge of its ability. Sorry, I'm just trying to make these panels fit while we're chatting here. Okay. And I'll be able to charge fully, flip the switch, turn the power down a lot, and put a little bit of a charge back to degauss it to whatever extent I want based on where I set the dial on that variable transformer. And I will have to go through, I'll just make an indicator that says, you know, A2, you know, 200 Gauss here, A4, 200 Gauss here, A5, 325 Gauss, and that way I can just dial it back to what I want. Now, the thing is, that dial will have to be replaced periodically as my magnet formulas change with each, not each batch, but, you know, periodically as I get new magnets, if anything changes. Alnico magnets are not always the same. In fact, they're usually not from batch to batch, nor from supplier to supplier. So, okay, let's see. That might be it. I'm just putting this back together now. I think I've explained everything. There's really nothing I can do. I guess I can demonstrate it with my my benchtop power supply. I believe has a 10 amp variac in it. However, the analog meter on it only goes up to 5 amps, and I have pegged it before and it's gotten stuck at the 5. It's a needle. It goes, and then it just stays there when you take the power off, and you gotta tap on it, and then it goes, oh, okay. So I don't want to do that. I don't want to use that as my experiment right now. This is a little tricky to put back together. I'm certainly stuffing it full. I hope that it is safe. Got my little New Mexico flag on there, where when I visited numerous times while I lived in Colorado and before. I forget what they call that. It's like there's a name for the sun in that pattern. I forget what it is. I think if I assemble this upside down, it might go better for me. So let's try that. This was inspired by that experiment that I did, but doing that experiment also made me remember so I've seen the magnet charger in 2 different ways that Gibson had at different times. So the one in Kalamazoo was described to me by an employee who actually saw it, although he did not work in the pickups department. So his description of it was a little, but he basically described it as a giant U-shaped piece of iron, like a horseshoe magnet with a coil wrapped around it. So it was like an electromagnet, a bar with coil around it, but then bent into a U, hooked up to a car battery, like an actual car battery. They said that they would have to charge that car battery periodically as it got weak. I also saw a photo of a industrial commercial made one, which was at String and Accessory Factory, and this was a little bit later. I have a photo of that. And that actually had a dial on it with lots of little handwritten markings. It was an old grainy black and white photo, so I couldn't tell you what those markings said. Oh boy. Well, I think we're going to just tighten this up and hope for the best. It keeps popping off there. I'm not sure what's bent, but I've moved this a couple times, so it may not be perfectly square. That's just something I will have to live with. Yeah, so that one did have a variable. The later one that Gibson used that I saw a photo of, that did indeed have a variable power supply connecting to it. And it had pole shoes just like these, and 2 big coils that were exactly like the one in here. So maybe I've done something right. Okay, let's call that good. I have to get back in here anyway. I forgot about that. So the main power switch for this on the front of the unit is a momentary rocker, and it needs to be replaced. These things are good for about this one right here. So off and then on, and then it springs back. Those are good for about 25,000 cycles usually. That's what they're rated for. And I've maybe I've exceeded that. It's possible. So it's failing to the point where sometimes it's difficult to turn on. Now, some of you guys are smarter than me who watch this, and I don't know why you waste your time watching me, but this is how I received the machine, with the chiseled end like that of these on this side, and the magnet goes in the middle. I've also seen them oriented that way, where there's a big blunt face in the middle. Is there an advantage? Now, I went with them this way, knowing that magnetic flux is greater when a piece of material comes to a point like that. However, this thing is beyond sufficient for Alnico in any of those positions. Okay, I'm gonna plug this into the Variac. And I'm gonna get the Gauss meter going here. This is what I use for, oh boy, interconnecting that little jumper wires inside. This is a big heavy duty outdoor extension cord, and it's full of this 12 gauge wire. So that was my source. Okay, I'll put this here. I'm going to do this right under the camera. Look, there's a warning on here. Let's read this. Caution. Intense magnetic field present. Persons with pacemakers, hearing aids, and any other sensitive equipment must be kept at least 10 feet away. This unit can reach surface temperatures that can cause burns or ignite some materials. I've not had it actually get that hot on me. Rarely, in fact, has it got warm, although it does after a day in production. It can. I'm going to put, this is the probe for my Gauss meter. I'm going to just kind of makeshift a little gap here. Put it there, let's say. And this is just to test my switch. I have ruined credit cards and a camera lens, but I'm feeling wild today. This is right under the camera phone. I'm gonna move it away a little bit, as much as I can. Pull it forward over here and off to the side, and we'll keep this underneath. Hopefully this is good. We're gonna watch the Gauss. I'm also not gonna, I have it plugged into my bench power supply so I can watch the voltage and the current. I'm only gonna operate this at first at like a few volts. So I'm gonna turn on the benchtop power supply. I'm going to hold in the power button on the charger and very slowly bring it up. We should see this go up fairly quickly. It does not take much, and that's a very sensitive meter. Yeah. We're at 8 volts, and it's already like, the strength of an Alnico 2 at full charge. Okay. So it's negative in that direction, and that is pulling 0.7 amps. Very insignificant. If I flip the switch, does that number go positive? That is the goal. Oh, yes, indeed. Okay. I'm excited. Let's take, this is an unoriented A5. I'm going to bring it back. Bring the charger back into view a little bit. Hope that that's okay. Pop it in here. Looks like the phone is still working. It's probably going to take like absolutely nothing to knock the charge back. All right, so probably need to make some kind of new fixture to hold that in place. All right. Yeah, okay. kind of like a firm fit. Okay, so I think the most I can really take this up to is about 55 volts. That's where we're at now. And I don't think it will give us a full charge, but I'll try. Yeah, and indeed that went up above 5 amps. Let's see what it reads. Yeah, 390. So no, it's not fully charged. However, significant enough. Now, if I put it back on the charger, let's try it again. So here's what I'm gonna. Oh, did I do that wrong? Did I do it backwards? Oh man, I might have installed the switch backwards. Let's see. There's my indicated side that used to go towards north. What do we have here? Yeah, okay. So north goes the other way now. I've installed that switch backwards. I can rotate it when I put the other switch in. Or I just, not care. Just label the switch as south. Okay, so that should be a high charge. Now if I take the power supply down to about, let's give it 2.1 volts, and hopefully it'll come out totaling something less than 350. No, 370. Let's try again. Oh, I didn't flip the switch. Here we go. Now let's see. Less than 350? Yeah. 250. Let's try that. One more time. 55 volts. Full charge. Okay. Reverse. Seven volts. Yeah, and I heard the magnet fall loose, so that's gotta be good, maybe around that 200 range. Oh, it went way too far. Yeah, boy. Okay, this is gonna take some figuring out. There's another one I could do though. I think if I add a small gap and see if that just makes it a little less sensitive in both directions. Let's see what that does. Let's try this. Now, I don't know if it'll fully charge at 55 volts. I mean, it wasn't before, so I don't know what it'll charge at 55 volts now. I think I might have to wait till that power supply gets here. It should be here Monday. Okay. Full charge forward. Well, not full. 55 volts forward. And what do we get? 350. All right. Reverse. Let's just start about 10 volts. See what we get. Okay, 9.1. What do we get? 250. I like that. Let's try again. 55 volts forward. Okay. In reverse, 10. $250. Okay. Now we're getting somewhere. All right. Well, obviously, I'm going to not go through and make a whole chart now because I'm only operating this at less than half power on this benchtop Variac, which is really only comfortably going up to 5 without risking my meter on it, amps. So But the theory's proven. It's good. When I get the power supply in, then I'll go through the different magnet types, make a chart, and I'll be able to dial them in and control it. I'm happy. All right, cool. So, all right, guys, we're going to come back and we're going to do some more long A5s and short A5s. Finish up our magnet comparison. All right, see you.